We're going to look at the bending behaviour of the St Pancras lighting system just for the moment. And it's not the whole story, but there is going to be some bending, and it's good to get a grip of how it's going to behave under bending. So we've got a diagram which is going to represent the lighting. We've got a fixed support here which is representing the sort of more stiff support at one end, and a pin support which is representing those two struts which attach to it, the front, as we can see. And the best way to understand how this is going to work is to look at the deflected shape. So the key to be able to draw a diagram like this is to look at the points where we know what's going to happen. So at the support here, we know deflection is going to be allowed, sorry, not deflection, but rotation is going to be allowed. So we're going to have some rotation here. It's obviously going to go downwards, that's the direction of the load. There's going to be no rotation here because we've got a fixed support. And at this corner we are looking to maintain a right angle. So we can start with those points and kind of join up the dots, as it were. And the next thing to do when we want to construct a bending moment diagram from this is to look at the points of contraflexion. So the points where the deflected shape goes from hogging to sagging. So this point is curving downwards, this point is curving upwards slightly. So we have a point of contraflexion just there. And what that means is there's going to be zero bending, because at this exact moment the deflected shape is completely straight, i.e. no bending. And there's also going to be a point of contraflexion just here. So we're going to be able to use these to put together a bending moment diagram. When it comes to the bending moment diagram then, we're going to start off with sagging at this point because we've got a deflected shape going downwards. We're going to end up with a bit of hogging here, and then the moment is going to transfer around this corner because it's rigid, and we're going to end up with a moment up here which is hogging in this direction. Let's get rid of this red line for deflected shape, and we can use that information to draw in a qualitative bending moment diagram. Let's hopefully get it right. So start off with this sagging moment caused by the load, the uniformly distributed load. Going to end up with a bit of hogging here, and then that's going to transfer around the corner, so around this way onto here. So this now corresponds to the bending at this point. And going to go up. You notice we've got zero moment where we had those points of contraflexion from before. There's a couple of features to this lighting system which help to minimize the effect of the lateral loads we're going to get maybe from the wind. So let's just look at them briefly. First off, we've got the shape of the profile. So as the wind is going to hit this profile, it's got an aerodynamic shape, the wind is going to be channeled around, and there's going to be less force directly acting on it. So that's one feature which is quite useful. But also, when we come to the curved member at the bottom of the structure, it's got its very skeletal looking structure. So because it's going to be head on to these lateral loads, the fact that it's got all these holes is going to again work to reduce the amount of lateral force affecting the structure.